Okay, so today we're going to look at how to name a binary ionic compound. Now, what the heck does binary mean? Binary just usually means two. So we're talking about an ionic compound that's made of two elements. Binary code is ones and zeros. It's just two different numbers. So if we're talking about binary ionic, it's just two different elements, but they're forming an ionic compound. Now, remember that an ionic compound has to be a metal and a non-metal. If you have two non-metals, that will be covalent, and you'll never have two metals bonding anyways, so it's always going to be metal and non-metal. Now, when we're naming these compounds, we always write the cation first. Now, if you forget what a cation is, it is on the backside of your periodic table. A cation is a positive ion. It actually gets its name from batteries. It's the cathode. That's the electrode. That's usually your positive side of the battery. And the anion is the anode, or the negative side of the battery, or the negative ion. Now, I know it looks like these, like if you're pronouncing English properly, we would call those cations and anions, just like an onion is not an on-ion, right? We pronounce that onion, even though this is pronounced an ion, not an anion. Because we're talking about negative ions and positive ions. So we speak things a little bit differently in chemistry. It's almost a little bit of a different language. So you have a lot of the ions on the backside of your periodic table. You also have the ability to figure out most of the charges on the ions on the front side because of what their valence electrons are. So we've gone through and we've figured out that column 1 is always a 1 plus and column 2 is always a 2 plus and so on and so forth because of where they are on the table and how many valence electrons they would need to gain or lose. So when we're naming ionic compounds, the naming of these is actually really easy because we don't even have to mess around with prefixes because we don't need them. So we just write the cation first, the metal. We always write metals first and then the non-metal. So we write the cation, the metal, and then we write the anion, the non-metal, and we shorten it down to IDE, so that "ide" ending. So sodium chloride, magnesium bromide. And we don't have to say any prefixes here because we'll be able to figure out, if I say the chemical name, whoever it is that I'm telling will be able to figure out the charge, figure out the formula based on the charges that we've already learned. You'll see what I mean in a second. So if we're going to name these NaCl, we just straight up say which elements are there. So this is sodium, and I don't need to say monochloride. I can just say chloride. Why not? Well, if I said sodium chloride, we would know that that's an ionic compound, so we'd have to look at charges. If I didn't know the formula, I would look up sodium and see that it's a 1 plus, and then I would look up chloride and see that it's a 1 minus. So to put them together, I only need one of each, so it's NaCl. I didn't have to be told how many sodiums or how many chlorines I need to put together because I have charges to work with. In covalent, we didn't, so we had to be told. So that's kind of the difference here. Naming is like texting. You're trying to say as much as you can in as few characters as possible. So if we don't need prefixes, we're not going to use them. We're going to try to keep this as short and sweet as possible. And if you remember correctly, lots of people get scared when you hear these complex chemical names. Well, the names can get quite big, so we want to keep them as short as we possibly can. So the next one, zinc is a metal, so this is zinc. And we don't need to say dibromide. We just say bromide. That's it. Now, again, why is it zinc bromide? Well, if you look on the back side of your periodic table, zinc is a 2 plus, and bromine forms a 1 minus. So Br is a minus. Bromide, if you look it up, it's also Br minus. So to put these together, I need 2 bromines to match up, or bromides, I guess, to match up with the zinc. So if I want to make that formula, it's ZnBr2. I didn't have to be told that there are 2 bromines. I will figure that out using the charges. Again, covalent, we didn't have charges to work with. So next one is just aluminum oxide, and that's it. Don't need charges. Don't need prefixes because we can figure out the formula based off the charges. So if somebody asks me, hey Hayward, what's the formula for aluminum oxide? I can determine using charges what its formula is. And I'm going to show you how to do that right away. So if we're going the other way around, to find the formula of a binary ionic compound, we're going to take the name and we're going to write the symbols of each element that they told us, and then we're going to figure out their charges. And we have to put the elements together so that the charges will add up to 0. Now, I'll show you a couple shortcuts, but the best way to do this is using the lowest common multiple. In other words, how do we get both of these to have the same number of positives and negatives? So here's an example. Magnesium chloride. If we're looking at magnesium chloride, we want to figure out this guy's formula. I know it's magnesiums and chlorines. We just don't know how many. So I got to figure out how to put magnesium and chlorine together. Magnesium has a charge of 2+. It's in column 2. It forms a 2+ ion. Chloride has a charge of 1-. How do we make them add up to 0? I'm going to need 2 chlorides to match up with the 1 magnesium so that our overall charge is 0. If I write it like this might help it make some sense. Here's Mg with a 2+ and Cl with a 1-. Right now I have 2 positives and only 1 negative. But if I bring in another chlorine, now I have 2 positives here and 2 negatives here. That adds up to 0. So we would need 1 magnesium and 2 chlorines. Notice I didn't have to be told dichloride because we didn't need the prefix. We got the charges to work with. Let's keep it short and sweet. So let's go through, we'll do a few of these together. The first one is lithium phosphide. So we look up lithium and we look up phosphorus. So lithium is in column 1, it forms a 1+. Phosphorus is in column 5, it likes to gain 3 electrons, so it's a 3-. To make this add up to 0, I need 3 lithiums and 1 phosphorus. So that's Li3P. If I write it like this might help you see. There's 3 positives and 3 negatives. That adds up to 0. Let's look at strontium nitride. Strontium is in column 2. It has 2 valence electrons that it likes to lose. Nitride, or nitrogen, is also in column 5 like phosphide, so it also forms a 3-. Now, the best way to think of this, the way that will never steer you wrong, is thinking of the words lowest common multiple, which you've probably heard of in math class. Lowest common multiple means what is the lowest number that these two digits, 2 and 3, will multiply up to. So 2 and 3, the lowest number that they both will multiply to is 6. To get 6 positives, I'm going to need 3 SRs. And to get 6 negatives, I'm going to need 2 nitrogens. And there would be your formula. Now, a short form of that is what we call the crisscross method. In other words, the 3 drops down to the SR and the 2 drops down to the N. But ultimately, really what you're doing is lowest common multiple, and that's the correct way to think of it, so I like to teach it that way. Really, at the end of the day, whatever makes most sense. So let's do another one, aluminum oxide. So aluminum and oxygen. We look at aluminum, it's in column 3, so it forms a 3+. We look at oxygen, it's in column 6, sorry, it gains 2 electrons, becomes a 2-. We need to match up 3 positives and 2 negatives. Again, the lowest common multiple of 2 and 3 is 6. So if I did this might help you see it. I have 2 aluminums, that adds up to 6 positives. Okay, to get 6 negatives, I'm going to need a total of 3 oxygens, that gives me 6 negatives. So basically I times this one by 2 and I times this one by 3. So what ends up happening is you get Al2O3. Another way to look at it is if you had Al3 plus O2 minus, we can crisscross them down and you get Al2O3. It's the same idea. Here's some for you to try. Pause the video, give them a shot, see how you did, and check your answers. Name for this one would be potassium bromide. This would be calcium chloride, strontium chloride, lithium oxide, and going the other way, beryllium phosphide. So Be is a 2+ and phosphide is a 3-. So this would be Be3P2. Aluminum sulfide, Al is a 3+, sulfur is a 2-, so Al2S3. Ooh, cadmium. And now cadmium is one we have a problem with, unless it is on the back side of your periodic table, which it very well might be. Cadmium, yes, Cd is a 2+. Now we're going to work with those ones in the middle a little bit more later, but cadmium is on the backside, so I'm going to go with it. It is a 2+, oxygen is a 2-. So that means now we're going to put these together, so it's CdO. Strontium iodide, so that's Sr with a 2+, and iodine is a 1-, so SrI2. So this is how we name ionic compounds and write formulas. And actually, most of the naming that we do in chemistry is for ionic compounds. There are many, many more ionic compounds than covalent ones.